Okay. So this one is very easy actually. This one's not very hard, thankfully. Because the last one was a pain. But this one just asking us what the work done on the head of the broom is. And since the head of the broom is moving horizontally to the right, we only care about the horizontal work. It's the horizontal force being applied. You can't even tell what that says. Never mind, bro. Oh my god. But yeah, we just care about the horizontal part. So just to solve that, we just make our triangle. And this part right down here is going to be uh, cosine theta. This would be sine, but that's not relevant here. So we just have cosine. But low key, half these have cosine. So which one do we do? We're given distance d. We're given mass m. We're given force F. Um, but the stuff that's like most important, like M is not really required. It just we need F and D, which is kind of a hint to our answer being B. But the reason why it's B is we're looking for work, right? Work is just equal to force times distance. This is the same thing as the earlier formula where we said that work is equal to energy final minus energy initial, whereas F times change in distance or displacement is also equal to EF minus O, right? These are the same thing. These are the same equations. I mentioned this in the last video, which means that work is just going to be equal to F times change in displacement. Distance is just that change in displacement, right? If this is our initial point and this is our final point, change in displacement would be, whatever this is minus this. That is just the distance, right? It's the same thing. So even though we're not given work explicitly, we're basically just being asked, okay, well, what's an alternative for work and how does that apply to the overall question? Well, the alternative is F times D. And if F times D is our work and we're just looking at the horizontal component of the work, then we just take F times D cosine theta. And that would be our final answer, which is